Welcome back to the channel. Hope everybody's doing well. In today's video we are taking a look at this little motor test switch box that I've built up. I've built this test box up to help me out when I'm doing some AC impedance measurements on motor windings, and all this is a voltmeter switch. If you have worked on industrial panels, you'll come across these voltmeter switches from time to time, and I'm using this to switch the AC supply that will come in at this side over to the motor winding, each phase in turn that will be connected into this side. All the components for this have come from RS Components, and overall this test box would cost me around about £80 to build up. The most expensive item being this voltmeter switch in the centre here. Dead easy to build up. Just flip this open in here and you can see these are 4mm safety jacks. I've just made little link wires to connect into the voltmeter switch. The circuit diagram for this is based on the actual circuit that comes for a voltmeter switch. Hopefully you can read this okay, and you can see in place of the voltmeter here will be my AC source, and then in place of the L1, L2, L3 will be the motor windings UVW, which will need to be in either star or delta configuration. At this moment in time, the neutral connection, I've actually connected that through the earth jacks here and taken that to the switch as well. So what I will hopefully be able to do then is use this for insulation testing as well. And I'll demonstrate the use of this on the little motor winding simulator that I've got. Dead easy to build up. This is purely basic hand tools that I've used. The only thing that's slightly unusual are these tools from Hirschman. These are for installing these safety sockets. I've got a spare one here, especially when they're mounted inside panels like this with a bit of reach inside there. The small tool locks into the centre piece, so it locks it there, and then the large tool here, and it locks onto the securing nut, and then you can spin them up and lock them down tight, and much easier to do. You can do it with long nose pliers and a little spanner on the flats here as well. You can do it that way, but these tools do make it a bit easier. And then we've just got standard 7mm spanner, a box spanner here, which is just insulated because it was to hand for me whilst I was doing this. And then I do have a little thin 7mm spanner from Engineer, so these will tuck underneath the connections here so I can get onto those. I did do that with the voltmeter switch removed, but that just makes it easier tightening those up, and so I don't actually wreck the sockets itself. So that's that there. We'll set this all up onto the motor winding simulator, and I'll demonstrate its use with the MTR 105. So our easiest way to demo this is with the MTR 105 here. I've set this up to measure the inductance of the winding. The output of the instrument here is just connected to my input jacks, which are blue and brown on this one, which will respond to the AC supply. And then I've got a 3-phase test lead set from RS Components. Couldn't find a proper brown, black, grey one or harmonised colours one. I had this old red, yellow, blue set here, so I'm using that at this moment in time, but I've ordered the parts up to make up a brown, black and grey test lead set, and a green and yellow to put the earth through. My AC supply would be connected into here when I'm doing an AC test, but for this purpose I don't need that. And we're on LCR mode, so if we go to actually to 3-phase, can't we? So we measure on L1, L2, hit our go button. We are 2.79 millihenries, so I can put that into L1, L2. We'll switch to L2, L3 and hit the test button again. And that's L2, L3, and then L3, L1. Test button again. There's our reading for that one. L3, L2, so we've got 2.5% differential between the inductance on my little winding simulator here. So as I say, this will be for AC impedance measurement. I'll demonstrate that in a different video because that needs a full AC source setting up. But that will be the basic functionality of the test set. Just aids my testing really. What I can do as well with this wired through, and I want to go to an insulation test, if I move my jack over to my earth, and then I can use any one of these, L1, L2 or L3 to neutral. If it was a split motor winding with open winding configuration, I could test each phase independently, but because of the way I've wired the earth and the way this voltmeter switch works, all I can do is the one motor winding test to earth. I can do that with this one here. You should hopefully see 1.58, 1.6 starts to go up. So that would be able to work out for an insulation test function as well. And that would be the basics for my little 3-phase motor winding test switch box. So I could also use this for measuring the motor winding resistance as well if I wanted to. Just have to be a little bit aware, because as well as just of our normal test leads that we would have, I've wired through the switch and through another set of test leads as well, and as you can see here we've just shorted everything out and we are actually measuring 4.5 ohms to 5 ohms on the switch here. So it is a little bit more resistance that you'd have to be aware of if you're going to test this, but I guess you could do it. It's fairly consistent through the switch there, so I could use it for that as well. So there you have it, that's my little switch box. To store it all, I've decided on this little pack-out organiser from Milwaukee. It just fits in there just nicely, along with some shadow foam to keep everything all tidy. This top layer here, this is for the crocodile clips. So I've got a brown, black and grey for the motor winding connections, and then a yellow for the earth. This lifts out here, and then underneath you can see I've got the switch box, which I can access with the crocodile clips in there, but that just comes straight out. And then I've got 3 test leads in here, a brown, blue, green and yellow for this side to go to the AC source. They are all done and ready. I'm waiting for some jacks for this set of test leads to finish this off, but this is the brown, black and grey and green and yellow to go to the motor case, and these to the motor winding there. So this will keep everything together in the case for whenever I need it. And also if I'm out working on site, if I accidentally leave something behind, like the crocodile clip, it'll be immediately obvious, I'll know it's missing. So hopefully that will discourage me from leaving anything behind too much. But the shadow foam here, this is a standard 30mm grey sheet I've just cut out, and then the 50mm blue section here is one of their pack-out inserts that they pre-cut the shape for you to go straight into the box, and then you just cut out whatever holes you need for whatever you're fitting into the case. So that's that there. This is, what was this, was 80 quid. I think this whole setup is more expensive than the test box on its own, with the shadow foam. Shadow foam isn't too bad, it's reasonably cheap, but the organiser itself and then making all the test leads up is what's cost me a fair bit as well. So that's just a little switch box that I've built up there. It's something typical for what I do to make my life easier. You can see I've got another one on the go here. This is for a dielectric discharge simulator. I'm waiting for some parts for that as well to finish that off, so that's still pending at this moment in time. But that'll be it for this video. Thanks very much for watching. Hope you found it useful, and I'll see you again in the next one.